Picture this: a drone slicing through the sky at high speed, small, agile, and incredibly difficult to hit. Traditional ammunition struggles to make contact with such a fast-moving target. But what if a direct hit wasn't necessary? What if the projectile only needed to get close enough? That's where the concept of a proximity fuse completely changes the game. Instead of relying on impact alone, a proximity-fused round is designed to detonate when it gets near its target. Not on contact, but in the air, right beside the drone. In modern combat, where drones are becoming smaller, faster, and more unpredictable, this technology has become one of the most effective ways to neutralize aerial threats. As the projectile is fired, it travels at incredible speed toward the drone. But embedded inside that round is a tiny sensor system, essentially a miniature detection device. Depending on the design, it may use radio waves, laser signals, or other forms of sensing to monitor its surroundings. As it closes the distance, the fuse continuously calculates how near it is to the target. The moment it detects that it has entered a lethal radius, close enough that an explosion will cause maximum damage, the fuse triggers detonation. This all happens in a fraction of a second. No direct hit required. The projectile explodes mid-air, releasing a cloud of high-velocity fragments that spread outward in every direction. That's the key advantage. Instead of a single point of impact, you get an expanding sphere of destruction. For a drone, which often has delicate components like propellers, sensors, and communication systems, even a few fragments can be catastrophic. A single strike to a rotor can send it spiraling out of control. Damage to onboard electronics can cut off its connection, rendering it useless. This method is especially effective against small drones, those that are hard to track and even harder to hit directly. With traditional rounds, the margin for error is extremely small. Miss by even a few centimeters, and the drone escapes. But with a proximity fuse, that margin becomes much larger. You don't have to hit the drone, you just have to get close. And, close, in this context is carefully calculated. Engineers design these fuses to detonate at the optimal distance, ensuring that the blast and fragmentation pattern intersect with the target. Too early, and the fragments spread out before reaching the drone. Too late, and the projectile may pass by harmlessly. Precision timing is everything. Modern systems are incredibly sophisticated. Some proximity fuses can even adjust based on the speed and size of the target. They're designed to ignore irrelevant objects and focus only on viable threats. This reduces the risk of premature detonation and increases the likelihood of a successful engagement. Now imagine a defensive system equipped with rapid-fire capability, launching multiple proximity-fused rounds in quick succession. Each round doesn't need to score a direct hit. Instead, they create overlapping zones of fragmentation in the air. For a drone flying into that space, it becomes almost impossible to avoid damage. This is particularly important in scenarios involving drone swarms, groups of unmanned aerial vehicles working together. Traditional defenses can be overwhelmed by sheer numbers. But proximity-fused munitions offer a way to engage multiple targets simultaneously. Each explosion creates a danger zone that can affect more than one drone at a time. The visual effect is dramatic. A round streaks toward the sky, and just as it nears its target, it bursts into a flash, almost like a small firework. But instead of a harmless display, it releases razor-sharp fragments traveling at extreme speeds. In an instant, the drone is hit, destabilized, and often destroyed. There's also a psychological and tactical impact. Knowing that even near misses can be lethal changes how drones are deployed. Operators can't rely on speed or maneuverability alone to evade incoming fire. The threat envelope becomes much larger, forcing more cautious and complex flight patterns. Another advantage is efficiency. Because proximity fuses increase the probability of a hit, fewer rounds are needed to neutralize a target. This is crucial in sustained engagements where ammunition supply is a concern. It also reduces the time required to eliminate a threat, which can be critical in fast-moving combat situations. Of course, this technology didn't appear overnight. The concept of proximity fuses dates back decades, originally developed for use against aircraft. Over time, it has evolved to counter modern threats like drones, which present unique challenges due to their size and agility. Advances in electronics and miniaturization have made it possible to pack highly capable sensors into small munitions. Today, proximity-fused rounds are used in a variety of systems, from ground-based cannons to naval defenses. They are a key component in layered defense strategies, working alongside radar, tracking systems, and other technologies to create a comprehensive shield against aerial threats. But it's not just about the hardware. The effectiveness of proximity fuses also depends on the integration with targeting systems. Radar or optical sensors detect and track the drone, calculating its trajectory and speed. This data is used to aim the weapon and time the shot. Once the round is fired, the proximity fuse takes over, making the final split-second decision on when to detonate. This combination of external targeting and internal sensing is what makes the system so powerful. It's a coordinated effort between detection, tracking, and engagement, each part playing a crucial role in the outcome. In real-world scenarios, conditions are rarely perfect. Drones may be flying at low altitudes, weaving between obstacles, or approaching from unpredictable angles. Weather, terrain, and electronic interference can all complicate the engagement. Yet proximity-fused munitions are designed to perform even in these challenging environments. They offer a level of adaptability that traditional rounds simply can't match. Whether the target is moving fast or slow, high or low, the fuse adjusts to ensure the best possible chance of a successful detonation. As drone technology continues to advance, so too must the methods used to counter it. Proximity fuses represent a crucial step in that evolution. They shift the focus from precision impact to area effect, from hitting the target to surrounding it with destructive force. And in a world where aerial threats are becoming more common and more complex, that shift can make all the difference. So the next time you see footage of a drone being taken down midair without a visible direct hit, remember what's happening behind the scenes. It's not luck. It's not coincidence. It's a carefully engineered system working at incredible speed and precision, detecting, calculating, and detonating at just the right moment. All it takes is getting close enough.